Hello and welcome, my dear grade 10 elite students, to my channel Mathematics Made Easy. This is Ms. Ruchika welcoming you to today's session. This session is in continuation with the last video that I put on my channel for part 1. So the remaining questions we'll be covering today. These are going to be multiple choice questions, very important for your coming exam. So let's get started. We are going to be solving the quick check questions 1, 2, 3, and 4 using the famous theorem called Pythagorean theorem. These are all right triangles, so to find the measure of the missing side, you are going to use the Pythagorean theorem. In case you have forgotten, I'm going to revise for you this theorem. Pythagorean theorem states that if it is a right angled triangle, then the square of the hypotenuse, that is the longest side. So for this question 1, it is x square is going to be equal to the sum of the squares of the other two sides. So this is 121 plus 16, which is going to give you 137. So x square is equal to this value. You need to find x. So we are going to take the positive square root. And when you convert it to decimals, it is going to be near about 11.70. Okay, so that is for the first one. In the second one also, we have to find the longest side. So we have to apply the same theorem. So x square is going to be 12 square plus 9 square. This is going to be 144 plus 81, which is going to be 225. Now you take the square root for x. It's a perfect square of 15. So 15 is going to be the value of x for question number 2. For question number 3, the hypotenuse or the longest side opposite to the right angle is already given to you, that's 22. But you have to find this x, so I'm going to apply 22 square. It's going to be equal to the sum of the squares of the other two sides. So 22 square is 484. 8 square is 64, so x square is going to be 484 minus 64, that is 420. And for value of x, you have to take the positive square root. So it will come out in decimal near about 20.49. In a similar way, use Pythagorean theorem for the value of x in this last question. Simplify, and this is going to be equal to 233. That's the value of x squared. So x is going to be the square root of 233. That is near about 15.26. So that is how you apply the Pythagorean theorem for the right triangles 1, 2, 3, and 4 and get the value of x. Next, we move on to the angle in standard position. For this one, you have to draw for these angles which are given the angle in the standard position. So let's do it on the next slide. Let's draw these angles in standard position. The first angle here is 160. It is a little less than 180, so little less than a straight angle or half angle. So because the measure of the angle is positive, definitely the direction that we are going to take is counterclockwise. That means opposite to the direction of the clock. Wherever the angle is positive, the direction is going to be counterclockwise or anti-clockwise for the terminal side. Whenever the angle is negative, it is going to be clockwise. Okay, so plus 160, that is, you start from 0 and you move on till 160. The terminal side here is in the counterclockwise direction past the positive x-axis. So this is how the angle is drawn. Then 280 is a little less than 360, that is a complete angle. Again, the angle is positive, so we are going to rotate the terminal side counterclockwise. 280 is, if you subtract half angle from 280, that means 280 minus 180, it is going to be 100. That means from this point we are going to draw 100 angle. So draw the terminal side 100 counterclockwise past the negative x-axis. So this is the negative x-axis. From there we draw 100 in the counterclockwise direction. So this is the terminal side 280. Now 400 is little more than 360, so the terminal side of the angle will make more than one rotation counterclockwise. So one complete rotation you make, that is 360, then you subtract 400 with 360, you get 40, so you have to make 40° more. So first make a full rotation, and after that you continue the rotation and draw the terminal side of the angle 40° counterclockwise past the positive x-axis. So this is where the angle will be drawn. Next is 185. It is a little more than 180. To be very precise, it is 5° more. So the negative x-axis represents 180. So this is complete 180, and then you draw a little bit more. That is 5° more on the terminal side, 5° counterclockwise past the negative x-axis. So that's your 185 degrees angle. Then 810, this is a big angle, so we are going to take more rotations. To be very precise, we are going to take more than 2 rotations, and the terminal side of the angle will make more than 2 rotations counterclockwise. So this is the first rotation, this is the second rotation. Now after 2 rotations are done, you subtract 360 twice from 810. What you are going to get is 90, therefore it's going to be a right angle. So from positive x-axis, draw the terminal side of the 90° counterclockwise from here. So that's how you draw it. Then 390 is a little more than 360. To be precise, it is 30° more. So the terminal side of the angle will make more than one rotation counterclockwise. First make a full rotation starting from the positive x-axis, then continue the rotation. Draw the terminal side of the angle 30° counterclockwise past the positive x-axis. So this is going to be 30°, a little more than the positive side. Next angle is 495. This is 135° more than 360. So one complete rotation you are going to take, and after that you will move in the counterclockwise direction from the positive x-axis by an angle of 135. So this is how the angle is drawn. Next is minus 50. Now this is different because the angle is minus. That means the direction is opposite. So we are going to take clockwise direction. Okay, so rotate the terminal side clockwise and you are drawing 50°. So from here to here it is 50, little less than a right angle. Then minus 420 is again having negative sign, so it is going to be in the direction clockwise, and the terminal side of the angle will make more than one rotation clockwise. First you make a full rotation, that is minus 360°, and then you make minus 60° more in the clockwise direction. That's your angle minus 420. In a similar way, like the previous questions, you have to draw the angles for question 10, 11, 12, 13, 14 and 15. I have provided here the detailed solution so you can check your answers and draw the angles. Okay, let's solve question 5, 6, 7 and 8. We are going to solve these questions using basic knowledge of trigonometry. So we are going to use So I hope you remember this is the short form for sine theta, cos theta, tan theta. Sine theta is opposite over hypotenuse. Cos theta is adjacent over hypotenuse. And tan theta is opposite over adjacent. So I'm going to use these for finding the values of the unknown x and y here. So first of all, this angle is 45, then this angle is also going to be 45 by angle sum property. So here for this question, because both angles are 45, these two sides are going to be equal. So x is going to be 9. That's the first thing. And for y, you can use the Pythagorean theorem. Y square is going to be 9 square plus 9 square. So this is going to be 9 square root of 2. Okay, that's the value of x and y for question 5. Let's go on to the next question. Here you are given an angle 30°. I'm going to use the trigonometric ratio of tan. So tan 30°, so Katova, tan is opposite over adjacent. So opposite is given to be 8, adjacent is y. So from here you can find the value of y, put the value of tan 30, which is 1 by root 3. So y is going to be 8 square root of 3. Now that you have the value of y, you can find the value of x also. So how much is going to be x for this question? Can you do it by so there are two ways of doing it. X you can find either by Pythagorean theorem, or you can also use trigonometry. I'm going to use trigonometry here. So I'm going to use the ratio of sine 30 degree. So SOHCAHTOA again. So sine is opposite over hypotenuse. So opposite is 8. Hypotenuse is x. So from here you can simplify, and your x is going to be coming as 16. Okay, let's come to question 7. Here the angle is given to be 60. I'm going to first use the sine ratio. Sine 60 is opposite over hypotenuse. So opposite is y, hypotenuse is 24. Simplify, so your y comes out to be 12 square root 3. After you got your y, you need your x. So for that I'm going to use cos 60 degree. So this is going to be adjacent x over 24. So x is going to be 12. Okay, so I used trigonometry for these questions. In a similar way, we can use trigonometry for question number 8. This is a pretty simple one. We are going to take tan 45. Tan 45 is opposite over adjacent, so x over 7. Now tan 45 is 1, so x is going to be 7. Now you have to find y, so y is going to be 7 square root of 2 by Pythagorean theorem. Okay, so that completes question 5, 6, 7 and 8. For the remaining questions that you see here, we are going to use the concept of coterminal angles formula. So I'm going to write it here for you. Coterminal angle formula. Make sure you learn this formula for your exam. So you have to find two measures of angle, one positive, one negative. So the formula is, for positive angle, the formula is theta plus 360 degree if the measure is in degrees for the angle, and theta plus 2 pi if it is in radians. For the negative angle, the formula is theta minus 360 degree or theta minus 2 pi radians. If you see the solutions of question 16 to 33, I have applied the formula that I showed you in the last slide for solving the questions and getting the positive and negative angles. For positive angle to 65, which is given in the question, you add 360 and what you get is 425 degrees. And for the negative one, you subtract 360. So this is the negative angle coterminal with the given angle. So when it is given in degrees, even if negative, the formula is same: positive angle plus 360, negative angle minus 360 to get your answer. However, sometimes in your ministry exam, they may also give you the angle in radians, like question 28, where the angle is 2 pi by 5 radians. So you have to use the formula for radians. You will add 2 pi and subtract 2 pi for positive and negative angle. Take the ratio LCM, and these are the two angles that you get. So even if the angle is given to be a negative one in radians, negative 3 pi by 4, for the positive angle you add 2 pi, for the negative angle you subtract 2 pi to get your answer. Okay, let's solve some more questions on angles and angle measure. So in these questions 54 to 62, you have to convert, if the question is given in degree measures, to radians, and if it is given in radian measure, to degrees. So let me give you the formula. When you convert degree to radians, you have to multiply by pi divided by 180 degrees. And when you convert from radians to degrees, you have to multiply with reciprocal, that is 180 over pi. So I'm going to show you in the next slide how to do that for all of these questions. And for questions 63, 64 and 65, where you need to find the length of each arc, the formula that we are going to use is S, that is the length of each arc, is going to be the radius multiplied by the angle theta given in pi radians. So if you see carefully, in each of them the radius is given. This is the radius, this is the radius, and this is the radius. Also theta is given, so I'm going to highlight with a different color. Theta is given the angle in radians, very nicely it is given. So you just have to multiply the radius with the theta. So multiply these two to get your answer. Very simple concept. Let's see the answer in the next slide. So on this slide, I have provided you the solution for question 54 to 63. And as I gave you the formula, when you have to convert from degree to radians, you multiply by pi radians over 180 degree. Now you have to be careful not to do the mistake of putting the value of pi as 3.14. No, that is not going to be there. When you have to give your answer in radians, you will always keep your pi as it is and just add the unit radians to it, like this one. Similarly, 6 degree multiply with pi over 180, that is going to be pi over 360. Even if it is a negative angle given in degrees, it will be giving you a negative angle in radians, like negative 2 pi by 5 radians. Okay, now let's do another one where you are given angle in radians. So for example, 5 pi by 2, this is given in radians. You have to convert it to degrees. So you multiply with the conversion factor 180 by pi. Now always when you convert from radians to degree, pi is going to cancel. So pi and pi khalas, and you simplify the numbers to get in degrees. So 450. Similarly, for a negative value also, if you have negative 7 pi over 12, you have to convert it into degrees, multiply with 180 over pi, cancel pi from both sides, and give the answer as a negative number. So negative 105 degrees. So please check your answers for these questions. Now, as I told you, for question 63, 64, and 65, it is a pretty easy formula we are going to use. That is, we multiply the radius with the angle in radians. And here, in order to give the length of the arc, you will put the value of pi as 3.14. Use a calculator and simplify. So this is going to be 4 multiplied with 2 pi by 3, which is 8 pi by 3. Now put the value of pi as 3.14. Multiply, use a calculator, simplify, and give the answer as a decimal point. So in a simple way and a similar way, you will do 64 and 65. Next, we move on to trigonometric functions of general angles. Again, we are going to use SOHCAHTOA here for solving the questions. So you are given one ratio, like for example in question 7 you are given tan, and you have to find all the remaining values. So all remaining values, what are all the values? Sin theta, cos theta, tan theta, then it's reciprocal, cosecant theta, secant theta, and cot theta. So these are the total 6 trigonometric ratio. One is given, remaining 5 you have to find out. So as I told you, the basic you are going to use is SOHCAHTOA. I've already explained this to you before. So sin theta is going to be opposite over hypotenuse. Cos theta is going to be adjacent over hypotenuse, and tan theta is going to be opposite over adjacent. So we are going to use that, and we are also going to use right angle trigonometry and Pythagorean theorem. So if you will have a right angle triangle given to you with two sides given, then you can find the third side. As you know, this is say c square, this is a square, this is b square, then c square is equal to a square plus b square. So definitely Pythagorean theorem along with the trigonometry of SOHCAHTOA will be used to solve the question. So let's see the detailed solution in the next slide. So for question number 7, the value of tan is given to you 8 by 15. That means by definition of SOHCAHTOA, opposite over adjacent is given to you. This is opposite, this is adjacent. So in the right triangle, you will take the angle A. This is the angle. So opposite, you are going to mark opposite to this as 8 and adjacent or near to it as 15. And then you find the value of C using Pythagorean theorem. So C square is going to be A square plus B square. 8 square plus 15 square, that is going to be 289. And you take the positive value for the length, so C is going to be 17. So this side is 17. Now that you have all the three sides of the right angle triangle, you can use the basic definition of trigonometry to get all the ratios. So sine is opposite over hypotenuse, 8 by 11. Tan is opposite over adjacent, 8 by 15. Secant is the reciprocal of cos, so 17 over 15. Cos is 15 over 17. Cosecant is reciprocal of sine, so 17 over 8. Cot is reciprocal of tan, so 15 over 8. So you see in these questions, even if two sides are given, the third one can be easily calculated using Pythagorean theorem. And then you can use the definition of the trigonometry to get all the remaining 5 ratios. In a similar way, here tan B, we are considering this angle, is given to you as 3. Now there is nothing here, so tan B can be taken as 3 over 1. So this is opposite, this is adjacent. So opposite to B is 3, adjacent to it is 1. So C square can be found using again Pythagorean theorem. That comes out to be square root of 8. So now you can find all the ratios. Sine B is opposite over hypotenuse. So opposite is 3, hypotenuse is square root 10. You can also rationalize. This method here is called rationalizing. So we multiply with square root 10 in order to remove the radical sign from the denominator, and this is the value of sine b. Similarly, the other ratios can be found using their basic definitions. Let's do one question on cos also. So if cos is given, that means adjacent over hypotenuse is given to you as 1 over 2, and we are taking angle A, this angle. So adjacent is 1 and hypotenuse is 2. So you can find A square as 2 square minus 1 square. So A is going to be square root of 3. Now that you have all the three sides, you can use the basic definition of the trigonometric ratio to get sine A as root 3 by 2, tan A as root 3, secant as 2, and then use the reciprocals to get the remaining ratios. With that, we have finally come to the end of part 1. Thank you for watching the video. I hope you found it useful, and if you did, please like, share and subscribe to the channel. Share the video with as many of your friends who are giving the 10 elite exam so that you can benefit from the video. All the very best for your coming exam. Bye students.